Hello class, today I'm going to work out problem number 1 on your partial fraction decomposition practice. So when you open up the practice, you're going to notice that the fraction has something kind of weird next to it. It has this like S symbol. In calculus, this stands for an integral, which is a fancy way of finding the area under the curve. And the dx means just a really small change in x. And the reason it has all of this stuff is because I actually got this problem from your calculus textbook that you'll use next year. But we're not interested in doing the calculus yet. We're interested in simply breaking down the fraction or decomposing it into its two parts. So when you do these problems, just understand they came from a calculus book. You could ignore the integral sign and the dx and just look at the fraction. So the first thing we want to do is make sure that the degree of the numerator is less than the degree of the denominator. And that condition is held as 4 is a degree 0 term, and I have x squared on the denominator. The second step is to factor our denominator. We want to make sure that we decompose the trinomial into its factors. This will factor into the quantity x plus 7 times the quantity x minus 2. And then we want to say to ourselves, what could have happened? What two fractions could have been added together to get 4 over x squared plus 5x minus 14? So some mystery numerator, I'm going to call A, over the first factor, plus some mystery numerator, I'm going to call B, over the second factor, okay? And these are the easiest type when you have degree 0 over degree 2. Okay, so what I need to do is look at how to add A and B, and I'm going to add them together just as I would in a normal problem. Remember, I'm going to need to multiply each fraction by its fancy 1 so the denominators match. Okay, so I'm multiplying the first fraction by the quantity x minus 2 over x minus 2. And the second fraction, I'm going to multiply by the quantity x plus 7 over x plus 7. Remember, a fancy 1 does not change the value of the expression. Now remember that is equal to 4 times the quantity x plus 7 times x minus 2, okay? And now I notice that these two fractions on the right can be added together because they have the exact same denominator. So what I'm going to do is I'm just going to put everything over one fraction. So A times the quantity x minus 2 plus B times the quantity x plus 7 all over x plus 7 times the quantity x minus 2. And I'm showing all my work here, but if you're really good at adding fractions, you might even be able to skip directly to this step here. So feel free to do that if you can, but just make sure that you're very careful. At this point, I have a proportion, one fraction equal to the other. I notice that in my proportion, my denominators are equal. What that means is that the numerators are equal to each other. So now I have the following equation to solve. I have 4 equals A times the quantity x minus 2 plus B times the quantity x plus 7. And at this point, my job is to solve for A and B. Those are my two mystery letters that I want to figure out. Keeping in mind, you really want to make sure that you leave this factored. Do not distribute the A, do not distribute the B. That'll make it 10 times as difficult. Now, since x is a variable, meaning it can vary, and it's unknown, we are allowed to let x equal anything we want. So the first thing I'm going to do is I'm going to let x equal negative 7. Now, the reason I'm doing that is because I want to cancel out this term here so I can solve for A. If x is negative 7, this will be 0 times b, which will drop b out of the equation. So I'm going to plug in x equals negative 7, okay, plus b times negative 7 plus 7. And this is going to go to 0, leaving me with 4 equals negative 9a. And I know that a is equal to negative 4 over 9, okay? Now I'm going to take this equation again, and this time in order to solve for A, I'm sorry, I did solve for A. In order to solve for B, I'm going to let x equal a really convenient number that lets this A term go to 0. So you probably guessed it, I'm going to let x equal 2. And in this case, I'm going to substitute in and I'm going to get that B is equal to positive 4/9. Okay? Now, what that means is when I go to do my calculus problem, which you will do next year, what you're going to do is you're going to come up here and you're going to say, hey, you know this fancy fraction? Instead of finding the integral or taking the area under the curve looking like this, we're going to decompose the fraction into simpler parts. So we're going to say that's negative 4/9 over the quantity x plus 7 plus b is equal to positive 4/9 over the quantity x minus 2. And this is the problem we will work on instead. And furthermore, if we do some keep change flip, okay, this is going to be negative 4/9 times the quantity x plus 7. And then here I'm going to have plus 4/9 times the quantity x minus 2. Now, if you are unsure and you are a little bit skeptical at this point, what I would encourage you to do is very, very carefully take these two fractions, add them together, right? Make sure they have a common denominator. And what you should get is you should get the original fraction that we started with here.